Hello, everyone, and welcome to our practice session about the length of a circular arc. Yep, you heard it right. So, we're going to have a practice. There's no more second part, there's no more third part of this subtopic. Because in this subtopic, we're just going to talk about how to find the length of a circular arc, and we already covered it in one video. So, we're just going to have a practice. All right? So, without further ado, let's begin. So, as usual, we're going to have true or false. First statement, the formula of getting the circular arc length is S is equal to R times theta, or arc length is equal to the radius of a circle times the central angle. This one is actually the easiest. So the answer here is obviously true, all right? Because based from our last discussion, this is the formula that you're going to use to find the circular arc length, all right? Next, the formula of getting the circular arc length is derived from the formula used in getting the angle in radians. True or false? Let me repeat the statement. The formula of getting the arc length is derived from the formula used in getting the angle in radians. The answer is it is true. All right? Let me explain. Recall that if you're going to find an angle in radians, you're going to use this formula. Theta is equal to S all over R. Again, S is the arc length and R is the radius. All right? So we can derive this equation in terms of finding your S. All right? So we can have some algebraic transformation. So we can just simply multiply both sides of the equation by R. So we will have R theta is equal to S. Since multiplying R in this side will cancel the R's, we will have S. Then we can simply just switch their positions. So we have S is equal to R times theta. Once again, I actually forgot what identity it is. But yeah, it is valid to interchange the sides between the left and the right side. So, yes, it is true. Okay? Now, to the third statement. When substituting the given angle in the formula, we can just simply substitute it regardless of its unit. When substituting the given in the formula, we can just simply substitute it regardless of its unit. True or false? The answer here is false. Why though? Before you substitute anything in the formula, you must consider one thing. And what would that be? The theta should be in radians. All right? It should be in radians, not in degrees, but in radians. I already explained why the angle should be in radians. So I suggest you should watch that video, which is the length of the circular arc. All right. So basically, to sum it up, before you substitute everything, make sure that the given angle is in radians. All right. So next, we can use S is equal to R times theta to find the arc length of an ellipse. Again, we can use S is equal to R times theta to find the arc length of an ellipse. The answer here is false. Why though? What is an ellipse? First and foremost, ellipse is just basically an elongated circle or an oval circle. Of course, in every shape, there's always at the center. So ellipse has a center. All right. Let's just say you are asked to find the length between the center up to an endpoint, vertically speaking. Well, what would be the distance here? Let me just put line 1 would be the same distance as the line below. So both of them are the same. All right. However, if you're going to draw a line which is not in vertical way but rather in different orientation, let's just say horizontal, you see these two lines are not even the same as this one, which is so obvious because you can clearly and visually see the difference between these red lines and these white lines. Let's just say this is these are line 2, right? So you can clearly see how long is line 2 from, no, so you can clearly see the length of the line 2 and the length of the line 1. All right. So this means it is not a circle because a circle, if you're going to draw it, okay, this is the center. Whatever your length of this line from the center up to an endpoint, which is the radius, by the way, would be the same length that you will be having another radius, but in different endpoints, just like this one. So let's just say this is 2 units. So you will have 2 units, 2 units, 2 units. All right. So therefore, we cannot simply use this formula to find a given arc length of an ellipse since that would be a different topic. All right. We use this one for circles, but not to ellipses. So to answer that question, or sorry, statement, it is false. Next. When substituting the given angle in the formula just to find the answer, we should disregard radian to find our final answer since it has units. Let me repeat the statement. When substituting the given angle in the formula just to find the answer, we should disregard, we should disregard radian to find our final answer since it has units. The answer for this one is false. Why is it false? This statement should be completely true if this phrase here should be it is unitless. All right. It states here that when substituting the given angle in the formula just to find the answer, we should disregard radian to find our final answer since it has units. All right. It's supposed to be unitless. Remember, we use radian to represent a number that is in angle, but not in degrees, right? And remember that when we use this formula, S all over R, all right, S, which is the arc length, has the same unit as the radius. So for example, 3 inches divided by 1 inches, what's the answer? You have 3, right? It's only 3, not only because 3 divided by 1 is 3, but it is also because the inches are cancelled. So no more inches. So you only have 3. So the thing is, this one is an angle. So we can just leave it as 3, but we can represent it as radian. Therefore, it is unitless, not because it has units. All right? Forgive me if my grammar here is wrong. All right? Basically, what I'm trying to point out here is that when you're going to substitute the angle in the formula just to find the answer, we can just disregard it to find our final answer. But actually not find, but to, how should I say this? How should I say this? Oh, ha, wait. Let me just, hmm. We should disregard radian to find our final answer. No, actually not find, all right? Forgive me. Because finding is like you're solving, all right? That's a different scenario. To basically, let's just say, to represent, finally, to represent final answer. All right. No, actually, yeah, it could be fine or represent because in the solution, when you're going to solve for the answer, you can just disregard radian. So in other words, yeah, this could be it. All right. Forgive me if my grammar here is wrong. All right. But anyways, we answered this statement correctly. Now, let's proceed to this next statement. If theta is equal to pi radians and the radius is equal to 2 units, then the arc length is equal to 2 pi units. Again, if theta is equal to pi radians and radius is equal to 2 units, then arc length is equal to 2 pi units. The answer is true. All right. Why though? We can prove that this is correct by substituting it in this formula. All right. So it's like you're already solving here. Okay. So theta is pi radian, right? Then your radius is 2 units. So we have pi radians. Again, just as I said earlier, we can just simply disregard radian to find our final answer because it is unitless. So we can just have 2 units times pi. So you will have 2 pi units. So the answer here is true. All right, the answer here is true. All right. I think these are the only statements that I can give. All right. So that is all, guys. And I hope you have learned something in this video. Don't worry, we're going to have a second part of this practice video, which is more on solving. All right. So that is all. See you soon.